Today I'm going to tell you about the project Lagoon Refresh as an example of a multidisciplinary approach to restore the coastal lagoon habitat in Venice Lagoon. The title of the project is Coastal Lagoon Habitat and Species Recovery in Venice Lagoon by increasing the freshwater input gradient. Some general information about the project. The lifetime was 5 years. It started in September 2017 and ended in August 2022. The location is Venice Lagoon in Italy. The coordinator of the project is ISPRA, Italian National Institute for Environmental Protection and Research, my institute. And the partners are Veneto region that have the competence of management of the river basin and the interregional superintendency for public works that have the competence for the management of the Venice Lagoon. Other scientific partners is the University Ca' Foscari of Venice and IPROS, private studios of environmental engineering. The project area is in the Venice Lagoon, in particular in the SCI of the northern Venice Lagoon. In the red square, you can see the project sites, about 1,900 hectares. And in the yellow one, the areas of the concrete measures, about 70 hectares. All us know the importance of the Venice Lagoon for biodiversity, for ecology, and for socio-economic value, and for tourist issue. That's why we have thought about this project. If we look at the two pictures, we can see much differences, in particular in the inner area of the lagoon. The left picture shows the Venice Lagoon in the 19th century. Large surface, all the green area, was occupied by ecotonal zone, salt marshes, and reed beds. In the right picture, we can see that actually this kind of habitat are very limited. From the end of the 16th century to 19th century, the river's diversion caused the decrease of freshwater input and the decrease of sediment input with an increase of the salinity and a strong reed bed reduction. Salt marshes surface decreased from 170 kilometers square to current 43 kilometers square. And so the principal goal of the project is to recreate the typical oligomesoline environment of estuary type and their services. And the main objectives are the recovery of the salinity gradient lost and to restore reed bed, to improve the degree of conservation of habitat 1150 Coastal Lagoon in the northern lagoon of Venice, to reduce the degree of eutrophication thanks to reed phytoremediation function, to improve the status of bird species included in the Annex 1st of Bird Directive that use the reed environment during the winter period and or for breeding, foraging or nesting. And to increase the presence of fish species attracted by the presence of low salinity environment. Another objective is to improvement of the trophic state of the habitat 1150 will contribute to the achievement of a good environmental status within the Water Frame Directive. And so to achieve the objective, we use eco-engineering by two types of approach, according to Elliott et al. The type A approach consists on restoring the hydrological processes and physical-chemical conditions necessary to a natural self-improving of ecological structure and functioning. To do that, we have realized a diversion of a freshwater flow from the Sile River into the lagoon and restoration of the intertidal morphology to sustain the reed development. The type B approach that consists on a direct intervention on biota with transplanted Phragmites australis and phanerogams. And in addition, we applied a management approach with a reduction of hunting and fishing pressure in the area. The hydraulic works consist of 2 pipelines crossing the right embankment of the Sile River, and you can see the hydraulic works and the diversion of a freshwater flow from the Sile River into the lagoon is gradually increased, starting from 300 liters per second to approximately 1,000 liters per second. Morphological structure consists in 2 lines of modular biodegradable elements placed on the lagoon shallow area in front of the freshwater intake area with the 2 functions: to contain the freshwater and to create a substrate for reeds. We can see the 2 lines of modular biodegradable elements in the drawn picture, and the second line was constructed with the experience from the first line. A numerical model was used to evaluate discharge variation in terms of salinity diffusion with inflow nil, and so pre-intervention, the salinity is about 30, and so it's very similar to the salinity of the sea. It's not a normal salinity in the inner part of the lagoon. As we can see here, on the left in the high tide and on the right in the low tide. Expected results in terms of salinity were from 30 to less 5 in 5 hectares and less 15 in 25 hectares and less 25 in 70 hectares. With an inflow of 1,000 liters per second, we obtained the expected result in terms of recovery salinity gradient, as we can see with this simulation, and on the left in the high tide and on the right in a low tide. And so the first results, the hydraulic and morphological action were completed in 2020. The sluice gates were opened at 1,000 liters per second on February 2022. And now the salt gradient was met to the target. In this figure, we can see the map of salinity distribution obtained from numerical modeling, but calibrated with the field campaigns and continuous data from moored probes. And so, as we can see, the objective in the salinity gradient was achieved. The next conservation action, fishermen, hunters, stakeholders are involved in transplant action after a training course. Once the condition of water salinity and topography required to sustain the target ecosystem were met, approximately 2,500 small clams and rhizomes of Phragmites australis were transplanted to accelerate the natural expanding reed bed process. All actions were made with small boats and manually, as you can see in this picture. The results in the figure on the right represent the result of mapping activity The first one in 2018, and so before intervention, Phragmites was present in a limited area near the seal embankment. In 21 and 22, we verify a good engraftment of the clothes and development of new plants along with the bank, and salt marshes close the freshwater intake. But a consolidated reed beds are expected here after the project. I want to remember you that the flow of fresh water flowing into the lagoon only from 1 year, and so it's not so long time. About the first concrete action in aquatic angiosperm transplantation comes from the experience of another life Seresto. During the project were transplanted small clams, approximately 3,000 clams and rhizomes of Rupia cirrhosa, Zostera nolti, and Zostera marina. In this case, all activity were made manually with the transplantation of small clots, but in a diffusion way. And here the results, aquatic plant mapping of 2021 show a development in an area of transplantation. Some results about bird life. The bird community immediately changed with the freshwater input and the presence of morphological structure. The presence of freshwater to clean their feeders, the morphological structure used as a roost, and the mud flat to feed attract birds. For example, an increase of the abundance of Mediterranean gull flamingo and little tern was monitored. For the rest of the community, for the species target strictly linked to the Phragmites, it is necessary giving the reed beds time to grow and develop. And about fishes results, good results. Immediately with the opening of the fresh water, fish fauna monitoring showed an increase of target species, Pomatocyspus canestrinis, as you can see in the first graph. In 2021, with the freshwater input, we verified a very increasing of these species. And an increase in abundance of migratory species juvenile of commercial interest, especially for mullets. And about stakeholder, as all we know, the importance of involvement of stakeholder as gun right stakeholder can make or break projects. We spent a lot of energy to involvement stakeholder in Lagoon Refresh. We involvement 2 categories of stakeholder. All authority that have a competence in Venice Lagoon, and so municipality, regional offices, reclamation consortia, district authority. And these stakeholders are involved before writing the proposal to condivide the choose and the objective of the project, and during the project permission phase, and now in the afterlife to guarantee the maintenance of the intervention, and especially in the hydraulic works. We organize several meetings, but we request official permissions, and we request modification of hunting and fishing regulation. Other category of stakeholder was people attending Venice Lagoon as a fisherman, hunter, and lagoon enthusiast. And they are involved before writing the proposal to perceive the idea, the sensation of our project. And during the project permission phase, to share the restrictions. And during the project, we organized several meetings to organize a training course for fishermen and hunter, and with an active participation in transplantation activities. And so, in conclusion, Lagoon Refresh is a multidisciplinary project. The lagoon habitats. The strategy of the project covers a combination of different aspects and tools, strong involvement of stakeholders, national and local authorities, fishermen and hunters organizations, an ecological engineering approach with 4 concrete actions: the diversion of a freshwater flow from the Sila River into the lagoon, the restoration of intertidal morphology through biodegradable structure, the reed and aquatic angiosperm transplantation with the involvement of local fishermen and hunters, a management approach with a reduction of hunting and fishing pressure, and the use of numerical models as supporting tools for planning, testing the results, and managing conservation action, and environmental monitoring performed before and after the conservation action. And as required in all life projects, we use a lot of communication tools, websites, social media, newsletters, scientific paper, meeting with citizens, student dissemination activities. And if you want to know more detail about the strategy and multidisciplinary approach of Lagoon Refresh, we have published a scientific paper recently in September in Frontiers.